Welcome, everyone. Thank you for joining me for this webinar. Today, we're going to be talking about adopting a GraphQL mindset when migrating from REST to GraphQL. My name is Michael Watson. I'm a developer advocate for Apollo Federation, but really I work with a lot of different companies, organizations over the years on bringing their graphs into production. And I think coming from the REST background is a very common standpoint. And there's a lot of questions, and we're going to kind of dig through a bunch of things and have some time for questions, look at some code examples, and really dive deep. Now, before we jump into it, just some housekeeping. So if you have any questions, be sure to ask them in the question and answer box. We have some people monitoring those. I'm going to get questions, I'll be answering them. We will have a survey at the end. Feedback's really important for us to make these webinars better. And of course, we'll have a recording of this that will be made available. It's just going to take a couple days for us to get it up. And one last plug, there is another talk coming up, establishing your schema governance best practices on August 12th. I think that's another big question whenever you start building out your graph. How are you going to make changes to your schema and govern that process? So definitely get into that one and register for that webinar. Now, for today's talk, we're going to talk about a couple things. So first, why GraphQL? And one of the other things we're going to talk about, I always get this question as well, should I use Apollo Federation inside of REST going to GraphQL? And then we're going to talk specifically of how not to make our graph feel resty. That's actually a common comment that we'll hear is, this is resty. And we'll have some time for questions after that, jump into a demo where we'll actually look at Apollo server and an API and actually exposing that through the REST capabilities. And then we'll go through another round of questions and wrap up. Now, first, let's talk real quickly about why GraphQL, right? And we're starting to see a lot more adoption in GraphQL, and it's only going to increase, right? You can see all these companies are just different companies that are using GraphQL in their production environments. And this is definitely not even an all-encompassing list. This is just a list of icons that I could put together on the screen, but there's a lot more. I'm sure there's a lot of websites and apps you use every day that are just using GraphQL, right? So everybody's doing it. This is a way people are using to attract talent. It is becoming part of what is expected inside of a modern development stack. So very common. And part of this is because it's powering better digital experiences, right? We want to have better digital experiences. That's going to make a better customer experience. And that's going to really lead to what those revenue numbers are after that. And a big thing about GraphQL is when you start having one graph for the capabilities of your business, you really have a lot more power. You have an understanding of your business, how it's actually being accessed through the data. And you also have a strategy now for when those new paradigms pop up. How can this new kiosk thing still use that same customer return functionality that this other API is using, right? You have these APIs that are capabilities, these REST APIs. They're all capabilities, and putting them into a graph exposes those capabilities for your business. Now, let's talk about Apollo Federation. So one quick question. Let's start a poll real quick. How many people are using GraphQL in production, some form, or where are you at with GraphQL? And we'll give that a couple seconds to complete and give everyone a chance to answer. But a common question I get when I'm coming in from REST into GraphQL is, oh, I also see Apollo's got this Apollo Federation. Should I use Apollo Federation? In general, probably not, right? We want to make sure that when we're going from our REST mindset into GraphQL, we're going to be learning a lot of new things, right? We're going to be learning, how do we get our GraphQL server into production? How do we meet the security requirements of our internal teams? How do we do caching in the right way around what our graph is? Or if we do any caching, right? These are all questions, decisions, things that need to be answered. And that's typically done through some proof of concept or getting a server into production. So you first want to get that first server into production. And the second thing about that is, even with getting that first server in production, really to federate a graph, and that takes multiple GraphQL servers together, right? So if you don't have one GraphQL server in production, federation isn't going to do much for you until you have that second server. So I always recommend just start out simple with just one GraphQL server if you're going from that REST to GraphQL world, right? So right off the bat, kind of cuts down the scope of the world where if you haven't run GraphQL in production yet, probably shouldn't use Apollo Federation until you start to learn those other things. You definitely can do it. I think you're going to have to learn about that environment. And I think the big thing is that's going to be a template for the future if you did want to move to Apollo Federation, right? This is going to be the learning curve that other teams that are owning their GraphQL servers, how they're going to do it. And it's very common in companies to have, one champion team kind of start the GraphQL efforts up, put that out there, and be that template for the rest of the organization, right? So that's a common pattern we've seen for successful teams. And one of the things that I think is really important is, your federation benefits really kick in when you have 2 or more servers. So like get that one server working, but I have seen companies do it where they have just used Apollo Federation. For example, they just went to GraphQL and went through that. And that's okay, but there's going to be more learning, right? You're going to have to learn how your team is orchestrating the graph router, which there's a lot of stuff out there for, but it's just an additional learning on top of that, right? So you just need to plan accordingly if that is a route that you want to go down. Now, just to talk about a little bit of the results that came out, a lot of people are in production with GraphQL, right? And so I think there's a little bit about the mindset, and then there is the exploration about federation. We'll actually talk in the demo a little bit about both sides of that and how you can quickly adopt and incrementally into federation with all the same concepts of what we're talking about with REST, right? But we still have, a quarter of the participants that are investigating GraphQL, right? So definitely when you're thinking about this, your proof of concept, your next steps really should be starting out with just one GraphQL server. You can start out as a monolith, and you can incrementally adopt into federation, other things, and we'll show exactly how you can do that at the end of this. Now, I just put this slide here more for like a TLDR, right? So you don't need to federate right away. This is something that can happen incrementally, right? We want to just simplify with one graph that we're going to start out with. And typically when you're even starting out, for that quarter of respondents, you're going to be starting out with one domain. Don't try and expose like all of your APIs. I've had plenty of teams tell me, we got 700 APIs. Where do we start? Find one piece of UI, simplify that UI to like, what are those domains that you're going to need to put together? Expose that into that monolith. And then as a future next step, you could start either breaking that monolith down, or you can add in a second subgraph and start federating those together. So it's definitely an incremental path inside of there. Now, I want to talk a little bit about probably the most common argument against GraphQL when I see it first coming into companies. And it's really about how your graph might feel resty. And what I mean by that is when you're coming from this REST background, you have all these APIs, these capabilities, and if they're exposed on your graph as just a one-to-one, it makes your graph feel the same as a REST API. And a lot of the comments will be, is this any different than like the REST API? And the feeling will be not as different. And a lot of times that happens when the API team is just kind of mandated of like, all right, put out a graph now from your REST APIs. And so maybe you add on, you have an Express API, and maybe you add on, a GraphQL endpoint, and you just start exposing things in there. Or maybe you're using Ruby and you have an API built, and so you add on, the GraphQL gem and kind of start exposing that way. These are great ways to get started, but as you start getting into it, you really want to be thinking about those APIs, your capabilities, and you want to avoid just exposing them one by one, right? You really want to be thinking about what is the business capabilities I should be exposing on my graph, and how should teams really be interacting with those capabilities, right? And I think as a general hint, you want to avoid CRUD in the sense, you shouldn't be able to read CRUD on your graph. And let's actually take an example and look at this. So let's take Apollo's UI, and we're going to take accounts as an example. So we have the Apollo Studio page where we have various graphs. So this is once you've logged in, you're into your account homepage. So there's a lot of information inside of here, right? And most commonly, you're going to have some root query inside of your graph that's querying into that account, getting that information. And there's nothing really wrong with that. That's totally fine. You know, that's pretty standard. One thing I would say is a lot of teams will put arguments inside of there. One of the ideas behind making your graph very nice and easy for consumers, so you want to try and abstract away little things like that. So like one of the things I think about with the ID is I'd probably try and get that from the bearer token. Now, if we think about like signing up for an account, we can sign up with a GitHub account. We can sign up with email. There's also an enterprise SSO type route inside of here, but you can see two sign up paths on the screen. And we have a settings, right? So you can update things in your account. You can see we have update name, upload image, update ID, right? So this is the UI of like the experience of what we're trying to drive, right? Now, when we start thinking about that, we even have a delete, right? So we just went through, we have like, you know, you can create an account by signing up. You can get to the account page. So you have to get account information. I can update things in about account and I can delete the organization. So like there's a CRUD right there, right? And so a lot of times you'll see this start to pop up. And this is really a great example of where the naysayers have the argument of this feels like a REST API. And it does, it really does. And part of it is when you start writing the queries and how the client's going to consume this, a lot of it feels like the same of how they would interact with that REST API. And so this is an opportunity to start breaking that apart and pulling that down into a different format and everything around that. Now, inside of this, we can make it a little better, right? So we can start to break out things like that update account, because one of the things that's challenging is what fields can I update, right? Maybe you put all of those fields together. So what some teams will do is they'll make more of like an update account, and that will have an input with all optional fields. And those are the fields that you can update on the account. One of the challenges there is the granularity that you get in your observability stack. It's hard to understand, you know, is updating the account's email address versus updating the account's actual address for billing purposes, different performance wise. You know, you might have an API endpoint that does all of those things, and that's okay. It's part of the services, the underlying data source services concern of how you want to orchestrate those things together or do those things. And then you can expose it on your graph however you want, right? So you may have that API endpoint that's just /API/accounts, and you can, you know, do gets, puts, posts, you know, all of that based off of an open API or something like that. But you can just make separate calls on what those updates are with specific fields. So now a client consumer knows I can update the account's email address by this string, right? So we're getting better, but this still feels a little resty, right? And part of it is because we're just now adding like these update account and this root mutation field and the root query field, they'll start to grow over time. And it gets a little convoluted to where, you know, sometimes I want to like scope things into like exactly what I'm trying to look at or what I'm trying to interact with. And so one pattern that I like sharing is actually how we do mutations at Apollo. And it's, I kind of like to think of it as like nested mutations. But there's this concept where you can really make what the consumer is trying to consume, as far as I'm trying to work with an account, I'm trying to work with a product, I'm trying to work with an order, kind of like how your APIs are thought. And this is accomplished through an account mutation type, right? And what we're really doing here is when a client consumer is consuming into this graph, they may have something they're trying to get into. And as they start coming in as a new person, you know, they just type in mutation and look at what's available inside of there, right? But now there's some scope inside of there. All right, so now I'm inside of the account. And oh, it looks like I even have a typo in here. This is supposed to be account mutation. But that account returns account mutation. And inside of there, you have the various functionality and capabilities broken out, right? So underneath an account, I can update the email. I can add an address. Maybe I want to add the address as the default, or maybe I want to set a default shipping address inside of there. And when you start to look at this, it becomes very easy for an outside user, someone new coming into the organization, to start to understand what are the capabilities that I can start getting from our graph and how I can start using it. Now, I think there's a couple things. This is, definitely not the only way we do mutations. I think there's some good examples. We do it for our graphs and our accounts, but we also have various other mutations that are at the root. And I think what's really important is you're going to be building out your graph, and you're going to want to build a blend of what is the right thing for the data consumers. And this is one example of a pattern. Now, one of the things in this pattern as a caveat, because the account mutation is its own type, we make the assumption that you're always only going to be sending one mutation at a time. If you sent, for example, the update email and the add address, those will be sent in parallel. Part of the GraphQL spec is that any mutations at the root field will execute serially. But in my experience, I've rarely seen anyone ever have like two mutations sent in one GraphQL operation. So that's one caveat that I'd put around this pattern, but it's a great example of starting to group functionality in ways that make sense for your business, right? And so I think that's one of the important takeaways from coming from a REST mindset into the graph. You may have this giant API response like, Michael, the account returns 1 million fields. That's okay, right? You're going to want to cut a lot of that off from what that API response is for like what this account service is. And, over time, you may want to break down that account API, right? Maybe you want to also break that down to microservices. The nice thing about the graph is that also now decouples things to where you can start breaking down those microservices. So don't be afraid to drop that API response. Definitely don't take the whole account JSON object and just turn that into a GraphQL object type and put that in your graph. That's definitely what you don't want to do, right? Because you don't want to just add fields to your graph that aren't being consumed by the data consumers, one, but also just it's extra noise on your graph. And it's hard to contextualize exactly what capabilities you want to drive. And I think this is a great place to have product managers start to be involved of, what is the functionality we're trying to drive? Every time we're building a new feature at Apollo, our product managers are all part of that entire experience. And really a big part of it is what is the right way of how this is going to be consumed and used by our users. So I think that's really, really important. Now, I see some questions coming through inside of here, and I think this would be a good moment just to look through some of those questions. Now, I saw from Javier, N+1 is one of the most common issues faced by thinking in a RESTy way when getting into GraphQL. Batching is one way to tackle it, and caching is two. Is there another recommendation from your side to work around it? Yeah, this is definitely something that comes in, and I think batching and caching are the very common way to start approaching this. There's definitely a world of what we're working on with federation around this concept of entity caching, where there are entities you're defining in a federated graph. Those commonly map to a lot of these APIs. There's various things that could be added caching wise to help with that N+1. A lot of teams will use a combination of data loader and caching inside of there. And I think that's what the most common pattern inside of there is. But if it's a really big problem, a lot of teams will destructure that API and they'll do some field migration to what this new microservice is that's more fit for the capabilities of what you're trying to provide on the graph. You start out with one server and a monolithic one and have different subgraphs. I know by experience that the graph gets big real quick and it's hard to imagine in a single file. Yeah, there's definitely a lot of ways people do this. If you think about the schema that you can pass to an Apollo server instance, you can actually create submodules of the schemas and resolvers, and you can have multiple things that are put together inside of there. But it definitely is a challenge as the graph gets big. And I think that's one of the reasons why a lot of teams look at Apollo Federation. And also one of the reasons I recommend starting out with just one domain API as a starting point, because you may quickly realize and want to go in the route of federation after you have your first, thing, GraphQL in production live. There definitely are a lot of teams though also that have a giant monolith, and that becomes one of the subgraphs in a federated graph and starts breaking down into multiple subgraphs. That's actually a common pattern that I've seen. And you have client consumers essentially switching over from consuming the monolith directly to now consuming the federated graph inside of there. All right, let's get through. I'm just actually check time. Oh, we got time for the rest of these questions. Rahul, can you please point to security, mainly around data authorization based on user profile, and how it can integrate into data governance tools? This is a great question. So one of the first things to think about, like when you're coming from REST into GraphQL, is a lot of what you do for your REST world today is actually going to be the same for GraphQL. So a lot of your authorization type stuff is actually going to be very similar, the same. It's very common for teams to have some sort of API gateway technology sitting in front of their GraphQL layer that's doing things like, destructuring maybe a bearer token into an identity with integration into their identity provider, along with some like rate throttling based on, whatever criteria that they're putting together. I think that's definitely an area of GraphQL that's a little more bespoke from company to company, mainly because there isn't like an amazing solution out there for rate limiting inside of there. A lot of teams will do it based off of like some complexity count. There's a complexity directive a lot of teams will put inside of their schema to say what the complexity is for certain types or fields, and set a max value that you can't exceed this threshold, which works. Most commonly, I've seen that used as network hops. So for example, one team that I worked with, they didn't want to have more than 30 network requests per a GraphQL operation coming in from any user. And so that's what they use that complexity directive for, is actually to count, if you're going to query this field or this type, that's going to require this many network requests to our backend APIs. And that was a mixture of various data sources inside of there. So, that is similar to actually how they did things before they got into GraphQL. Was, the API rate throttling worked that way. It's just more of grouping them in a different light, but that's typically the same pattern or how you're going to do it at that API gateway layer. One of the other things I think about or hear a lot about is, do I integrate my auth service and everything right into my graph layer? You definitely can. A lot of enterprises and larger organizations have some service typically that's integrated that manages like identities and everything like that. And typically there's a lot of integrations where that bearer token is trusted, for example, when it's coming in the context of your GraphQL server because of that layer that's on the outside. So what I like to think about, especially with federation, everything, GraphQL is your orchestration layer. The downstream services is where all that business logic, all that stuff is living, right? And then you have an onion architecture that's really around your graph router, right? And that's where your authentication is one of those layers, your rate limiting is one of those layers, whatever the security requirements of your business. Now, integrating some of those tools is challenging. We actually just released OpenTelemetry support inside of Apollo Federation with Apollo Server. I think that's a great example of like information that you're going to need to do security things, and that's really now integrating into whatever your stack is, Zipcan, whatever you're using for OpenTelemetry. So our team, if you're definitely have more questions, I'd recommend reaching out to us through one of our contact us forums or in our community support, because there's a lot around this, and I think there's a lot more follow-up questions into like, well, what are some of the concerns you're in right now? All right, so 2 more questions, and then we're going to jump into a little live code demo. So if we break into multiple mutations, when user can update all the fields in one SMIT, will it be overhead? Well, this is going to come down to, honestly, how you want to design your graph and how you want to have that experience capabilities. Like if you want to have one update account and that has the ability to update any fields, and they're all optional inputs. It gets hard for a consumer to understand really like the capabilities around that account, but like they can see like these are the input fields and what they can consume, right? But there's not going to necessarily be overhead. It's going to be whatever the overhead is in your system, right? So in the code example we're going to get into in just a minute, we'll show how we're going to use essentially the same API endpoint for multiple pieces on our graph. And we're actually just going to change what the data is we're sending them, right? So we're kind of like switching where that abstraction layer is to make it easier for the client consumer. All right, one last question. Can we have some samples of one type extending another type inheritance? Currently, we are using interface, but it will result in repeating the same multiple times. If we have to change a name and of one field, we have to update them all. Yeah, I'm trying to think of the best way to say this. In my opinion, one of the things I think about is like interfaces, I see them get overused a lot. And there's a world where like I would say look at the queries your consumers are actually making, and in my experience, a lot of times a lot of the interfaces are actually used more as like the server team trying to like force an implementation detail into like your graph and your schema versus the flexibility of like what a consumer is trying to query with inside of that graph and how interfaces are used for that. Now, one thing I would say is Apollo Federation, extending types through that spec and the directives is actually one example of how teams break things apart to make this easy. This challenge, it partially comes from a monolith that grows over time and patterns that repeat over time. And so it might also be a time to consider like, is this a way to maybe, or this is a time to maybe restructure our schema, or maybe even be destructuring this into, kind of multiple things. Definitely would love to hear more about that. Maybe if we have some time at the end of this. Now with that, I want to get into a demo using Apollo Server and talk about exposing some REST capabilities and everything in there. And then we'll have some time at the end for more questions. I see a couple more coming through, so feel free to keep popping in anytime you have those. Now, let me pull up a page real quick. So the example I wanted to go through today, I just typed in orders API, REST API into Google, and Shopware was one of the ones that popped up. So I actually went through and looked at their examples. So if you wanted to like look at what the starting point of what this example is and how we're going to get in, this is actually where I started from. Now, if we're, I have Visual Studio Code open up right now, and there's a couple things I want to talk about real quick. This is actually the JSON object for the order, right? And there's a lot of stuff in here, right? And this is very common. I have a lot of teams say like, well, what do I do? How do I break this apart? My API returns everything, right? And really, if you think about like this details, let me make this text a little larger. If we look at this details looks like it's really like the actual item that's part of that order, right? And this API is returning just everything together with this order based on that order ID, right? And so in our first implementation, we don't want to necessarily copy everything over. Like, is a temporary ID ever going to be displayed on the UI? Maybe, but maybe not. If it's not, I don't want to expose on my graph, right? And even things like order time, maybe I actually want to expose that on the graph in a more consumer-friendly way, right? If I think about like this order time, this is not the order time that's being displayed in the UI app, whatever is being shown. That client team is writing some code to format that into whatever it does need to be, right? So there could even be a field that's formatted order time, and that's exposed on the graph versus order time. Or you can expose both, right? Where you have the raw and the formatted. One of the great things about GraphQL is adding additional fields is free, right? So we can add additional fields, we can remove fields, we can be flexible about this. But really thinking about the consumer, how they're consuming that, and what's the right best way for that to happen. Now, to start out, I also have this tool called Apollo Workbench. This is a tool actually I built working with customers on designing schemas. It is around federated graphs. We're actually just going to use it to look at designing this one schema out. So let's think about, here's our JSON, and let's actually talk about designing out a schema that's associated with that, right? So before we get into writing any code, the first thing we should be thinking about is like, how do we want to expose this order and this object that's inside of there? Now, before this, I kind of did a little bit of pre-work and put some stuff together for us to talk about. One of the first things I did is I created what our order is. I put an ID. I found a couple of things in there. I saw there was let's pull these up side by side, actually. I saw there was like an order number, there's an ID. I saw there was a customer comment, an internal comment. So I just copied those over. I didn't copy everything that I wanted to, but it's an example of, I don't want to necessarily expose everything. Maybe I always want to expose some things. I would expose some root for that to happen. Now, I have a couple examples of different mutations inside of here. And I think this is one of the areas I want to focus on to show some of the options of what you can do. And I think one of the things I get the common question is like, just tell me how I should do it. Should I do it this way or should I do it that way? And one of the things about GraphQL is you can do it both ways if you want it. You don't have to pick one or the other, right? We were talking about the pattern of like that nested mutation, but also having like just like an update order. You can have both in your graph if you want, right? And sometimes that might be necessary, especially if you have a graph that's like a public API of what you're trying to power. There's a chance that you may not think about the functionality or whatever you're trying to accomplish with, that said thing. I think this is actually one of the common reasons the node interface in the GraphQL relay spec became like a common pattern of, okay, well, now we have this like anchor point of how we can now do these mutations around this root for someone who doesn't necessarily know our graph, but wants to enter at a certain point and traverse. So we have both of the options here. So let's talk about the update order first, right? So we're exposing that order and being able to update it. This order update input, these are what are the things that we can change. If we actually go back into here, into our introductions, we have the update order. So currently it's only possible to update the following fields of an order. So these are actually the fields that we have as the input right here, right? So those are the fields that you can update, right? Now, this is where I mentioned when people say like, this feels like the REST API, because it is. We just looked at the REST docs. And we said, this is what we can change. So we added that here and we made that change here, right? And this is kind of how that mutation from a client standpoint would look, right? I have this update order. I'm just going to send whatever that order input is, and it's going to be whatever variables that I put together in that input. And, maybe I return the ID or whatever I want here, right? But the thing that I start to lose is that granularity. Am I really updating, the payment status? Am I really updating the comment? Am I updating all of them? Does my API perform worse when I'm updating all of them versus only updating one of them? That service layer underneath that probably is that API doing all of this could actually maybe interact with 10 other services underneath it, right? Remember, it's the service boundaries, or that service layer is concerned. And that's where that business logic code is going to live, right? So by breaking this out, we can start to understand the granularity from an observability standpoint. Meaning, if we think about that schema again, we have that order mutation. That order mutation has specifically update customer comment, and it has this comment as a string, right? So I know exactly what I'm doing on an order. So as a client developer, I'm writing the mutation this way now, right? So I'm actually writing into the order with my order ID, and then I'm updating the customer comment inside of here, right? And this could grow and expand, right? So like add, maybe customer comment is actually like a blank field, but internal comment, there could be a lot. So maybe there's an internal comment you can add, right? And that's on here as well. This is where now the client developer now can start understanding when I'm in an order, what are the things that I can start doing inside of an order, right? So it starts grouping that functionality in a way, and the root mutation field becomes slimmer, right? Because now there's order. And you can imagine this could grow and change order, accounts, more things that can be in there. And that's just an example of one pattern. There's a lot of other patterns out there as well. But this is kind of how we do some grouping of stuff at Apollo. Now, let's actually jump over into some code now, right? So we've talked about kind of the schema. We've made some things together. And let's say like this is what we wanted to go together and push forward for our proof of concept. So the example we're going to look at here today is using Apollo Server. Now, before I jump into Apollo Server, actually real quick, I was just using a tool called Apollo Workbench. It's a VS Code extension. It's in the marketplace. There's a blog post that actually came out yesterday that I'd recommend if you saw that and you're like, oh, that was cool, like designing schema like that and writing a query. Go check out that blog post. And if you have any questions or anything, feel free to open an issue or something on the GitHub repo. And when I get a chance, I'll check it out. Now, I have a little node project right here. I just did a simple npm init. All I did was install a couple packages, GraphQL. We're going to use Apollo Server for this example. And then we're going to use the Apollo Server data source REST. Now, this is a nice thing that we're going to kind of talk about what it adds in on top of everything. And, the question about caching that came from earlier, we're going to talk a little bit about the ease and the capabilities of caching inside of here as well. Now, I have inside of our index, I have our type defs defined. This is that exact schema we put together. So let's not look at that. I think the more interesting thing is starting to look at like these resolvers. Apollo Server is a very thin layer. We have those data sources. So we have this orders API that we created. We'll look at that in just a second. The question about authentication was asked. One of the common things that's done, right, is you typically have some headers or some values that are coming in on that incoming context of that request. Very common, that's in an authentication token on the header. And that's something that's typically passed to the downstream services and used. This context function is essentially the context creation for an incoming request. So you can take this function and turn it into whatever you need to like abstract something from the headers, maybe, do whatever you would. If you need to integrate something, you could, but most commonly it's used as passing the headers through different services. Now, the data sources. So I mentioned that REST data source API, and I think this is something that's really important. So specifically when you're coming from like REST into GraphQL and you're doing that first server in that API, Apollo Server has the REST data source class inside of it. And it's designed actually to make it really easy to interact with a REST API. So here's an example. I have a base URL that's defined. There are various other things inside of here. So, whether it's getting errors from response and having like, handlers for that, will send request is a common one. Maybe you need to evaluate something on the request or modify something before it's being sent out. There's a lot of different use cases and everything around that. But one of the really nice things is, all of the things like get, put, post, they're all right there available for you. And, we're simply just setting the base URL inside of here. And inside of each one of these calls, we are basically just providing whatever the path is and then any additional parameters inside of here, right? So if your API is something like API orders, order ID, this makes it really easy to integrate, what that get order by ID is. And you can see that we have like get order by ID. There's also get order by number. If I'm looking at the documentation inside of here, they have right here, loading a specific order. I notice there's two ways actually to get that, right? Use number as ID. So I can simply put that in based off of this REST data source, right? So now I'm kind of taking this API capabilities and I'm putting into like this REST data source. Now, a couple things to know about this REST data source. By default, it comes with a built-in in-memory cache. You can hook up a Redis instance, you can host a memcache and hook that up, or some distributed cache. So it's designed to really work easily with caching and everything around HTTP cache semantics. So if you have your headers set, all that stuff works. Now, by default, it's caching based off of the uniqueness of the URL for the GET requests, for example. Now, there's a couple options inside of here. Sorry. There we go. There's a couple options in the initial request. So per request that you're making, you can actually determine what the individual TTL that you want to set that's being sent to that individual URL, right? So this makes it really nice to where if you want to have different TTLs on different parts of like your API calls, like, oh, I know that the data coming from this API endpoint, we're good to cache it for 30 seconds. You can just set the TTL, for 30 seconds, and that's all going to work out of the box inside of here, right? So one of the common ways people deal with N+1 and everything like that, caching is one of those things. And this is a great, easy way to do that. Now, of course, it doesn't work for everything, as far as like, some objects just aren't cacheable. And that's to be expected, but very easy to get started out of the box. Now, what I really like about this is your data sources that you set in Apollo Server are actually available on the context inside of your resolvers. So we have our data sources set in here. We have this orders API. And if we look up here, we have our resolvers. And inside here, just right off the context, there's our data sources. And whatever our data source is, so we can have multiple data sources in here that will change and grow over time. You could structure it where maybe you have data sources for certain APIs, and then your server's that domain, and you now have multiple servers that get federated together. You can see how this might start to build up over time. And it's like Lego pieces, right? Now, one of the things that I think is really important, I like to say this outside the box because I think, I don't know, maybe it's just like a me thing, but I always like to set debugging up like from day zero, because I think it's so important to be able to contextualize and see certain aspects. Like I hate using console log to like figure certain things out. So if you're coming from maybe like not a Node JavaScript background, you're kind of trying to worry or figure about that stuff. VS Code Debugger is actually really good. I just added a launch definition inside of here for what we're putting together here, so that we can simply debug some of this stuff. So let's actually start up everything. And I'm going to focus our debug panel. So this is where the debug panel is in VS Code. You can see it, the console printed out that the server is ready at localhost 4000. Now, with Apollo Server 3, we have Apollo Sandbox as one of the defaults in here. I wanted to put this in here and not automatically redirect it, so you could see it and not be alarmed if, like, oh, that didn't pop up the same for me. But what Apollo Explorer is, it's really a way to interact with your graph that's running locally and everything. So we're able to run our server, start interacting with it and everything. And it has things like a schema explorer where you can look through like the SDL, everything that's inside of there, all from that server that's running locally. Now, I have this mutation up inside of here, the order, update customer comment. And one of the nice things is when you get debugging set up, it's really easy for me to now start like understanding, like contextualizing, okay, we're, inside of our graph, what are the various things that are available for me, and what are the resolvers being hit, and the chain of order, all of that stuff. So it's nice to be able to see that, like, here's that route that's coming in. You can see that on the arguments, here's that ID. I can set a breakpoint into like my next spot. Now here's the update customer comment. This is the next resolver that's being hit. Actually, let's just step forward one more. We can see there's order ID. There's the customer comment, right? So this is what's mapping all to that query that's being run here, right? So we're kind of now quickly able to see, and you can see this is now going into that data source and everything. So now over in my update order, I can set my breakpoint. Oh, I probably need to have it set beforehand. There it is. Yeah. Right. So now I'm starting to understand, what's actually coming into here. And I have a better experience of like trying to debug and figure out into this stuff. And I find this extremely helpful when you're coming from a REST background and you're starting to play and go back and forth between these things. Because a lot of it is understanding, I'm really going to be mapping my resolvers to a data source request, right? And as you start to build this out, this could easily become our first federated server, right? So before we jump out of this, this is just a single regular GraphQL server. But remember, I said it's really easy to incrementally adopt Apollo Federation. So let's do that. So we're going to install at Apollo Federation. That's going to be the package that we're going to use. So that's installed. Now, the main thing that's going to change is we're going to be using Apollo Federation's build federated schema to pull our schema together. Down in Apollo server, you can actually set the schema. We're going to build our federated schema, and we're just going to pass in our type defs and resolvers. All right. So now let's launch that. So now the server should be back up right here. Now notice that says this all of a sudden, enabling inline tracing for this federated service. All right, cool. Let's go back into here. Now there's a couple things. Now there's this service field. Okay, what's this? Let's actually just clear this out real quick. And now here's this SDL. This is actually part of the federation spec. And it actually returns the schema from that running subgraph, right? So we actually just upgraded that individual GraphQL server to be federation spec compliant, right? So when I say like, should you use federation at first? Well, like, don't think about that yet. You don't need to think about that yet, right? Start out with your first GraphQL server, and then federation can be an incremental approach adoption in. Now, some people might say, wait, but we didn't federate anything. You don't actually have to define any entities, any at key references of objects in your types. You can actually just use the same schema. I mean, other subgraphs won't be able to extend those types, but this is where it gets really easy for us to just start making that available. So inside of our order, we can easily add a key. Not odd, ID. I can't type this morning. Now, this is adding what is an at key. This is one of the directives in Apollo Federation. If you haven't heard of that and you are interested in going that route, definitely recommend visiting our docs, checking out everything there. But this is basically identifying that if you give me an ID, I can give you an order, right? And what that introduces is now we have our order resolver. And it's going to be a resolve reference resolver. Now, inside of here, we essentially have to return what the thing is, right, that we're getting. Well, we just said that we could just get it by the ID, right? It's probably going to be through that now, right? So what this is doing now is we've now added what on Federation provides that order as being available on your graph. Oops, looks like I have uncaught. Oh, whoops, yeah. Whoops, async. Async, oh wait. I've had so many people tell me, hey, you don't need to do that. And I say, yeah, but I come from .NET and I have to. My brain breaks if I don't put async and await. All right, cool. So now we have entities popping up inside of here with representations for the order. Awesome. So now our entity order has been exposed on the graph. And it gets really cool, right? Now we can start doing even more things. If we wanted to expose this in, for example, we said you can get it by the name or the number also, right? All right, well, if you give me the order number, I can give you that too. So now we go back to our resolve reference. And now if parent.id else and remember, we had a different method that we'd implemented, get order by number. So let's just take that and put that here. Right. And now we have supported 2 keys, right? And now another subgraph can extend the order and start putting information. So if we look at that whole JSON object, right, our order API could take care of whatever it needs to in here. And then for the items, it could just return, for example, these details, it could just return the IDs, right? And so now we can start having a federated graph that extends off of these orders. And now you have a product, or whatever they call the items in this service, a product service that is responsible for, you give me a product ID, I can give you what the product is, right? Things like this order ID, no longer needed, necessary inside of here. And you can start to see how now this API you'll have the desire to want to break this down after you go through this exercise in your graph. Now, I'm just looking at the time. I think this is a great spot to pause. I'm sure there's probably a lot more questions and things that popped up. I see a ton of questions all through here inside of this. I'm probably going to have to try and digest a bunch of this, and maybe I'll do a post on our community forums with some of these questions and just some general answers, because we won't be able to get to the rest of them right here. But picking up where we left off, why don't we get into some of these questions, and we'll pause here. Now, let's see. I'm going to just pick a random spot in this list because I don't want to go top to bottom. I feel like I'm just going to go right into the middle. Would you point one or more public examples of a well-designed GraphQL APIs? Ooh, that's a great one. Look, I'll say it like this. Anyone who has a public-facing GraphQL API, they're doing something right? Like they're being successful with that. I think Braintree is a good example one. They're actually an example of one that uses the node interface and the relay spec inside of there. There's also, Shopify's got a public graph. I mean, GitHub is definitely, a great graph to look at. I think those are big ones that just come to my mind. If you want to check out the Apollo graph, you can check out the Apollo graph. Obviously, I think that's going to be a biased opinion. I'm going to say ours is the best, but I think it's more, every graph has hints and things that you could take and pull into your own graph. Because there's reasons why everyone did what they had to do for whatever that is. So I would definitely check out those as some good starting points. And there's definitely a lot out there on the open internet. Sometimes I think it's fun to pull up Chrome DevTools and just, sometimes see like what GraphQL URLs pop up. And, a lot of times I can kind of see some graph stuff in there. So that's a good way also to just kind of see what's out there. I mean, if it's out there on the public internet, you can definitely maybe check out the graph. Back to that security question from earlier, I definitely recommend you don't have your graph in a way where that can happen. I just find it is the case everywhere, or a lot. Like, don't have introspection on in production unless you have to have a public facing API. That's why I mentioned GitHub, Shopify, those ones, and Braintree, because they have public facing APIs with docs that are associated with it, because I think that's important. Can you speak to database transactions and GraphQL if you want to run multiple mutations they're running in parallel? So what have you seen designing the ACID compliance system using GraphQL? I don't get too much into that. I'd say a lot of like the compliance aspect stuff and everything like that, that's usually where the scope of my stuff ends with the engagements that I typically work in. GraphQL is really the orchestration layer. And I find a lot of the enterprises and teams that I work with, they typically don't have their GraphQL servers talking directly to databases. They typically have some service layer. I have a lot of teams that standardize on like gRPC, and they actually have their GraphQL server subgraphs communicate gRPC. And, there's a lot of different, implementations, technologies, things that teams have found are better fits versus having GraphQL talk directly to that database. You definitely can, it's just probably more of like a scale thing. So if you want to update multiple comments, then end consumer has to call both mutations, correct? Yes, but what I'd say is anytime you have a world where you have multiple mutations that someone might want to do, that's actually a hint that you want to add some capability functionality to your graph that isn't there, right? So, in this orders API, did I put an example in here of this? Or I think it's from the slides. If we just went really quickly back to here, there's the add address is default, and set default shipping address, right? Because when you think about like, I'm going to initially create my account and I'm going to add address, but that address is also going to set as the default because I'm just like creating my account. So there's an additional mutation that's created that combines that functionality, and there would be some service layer underneath that combines that, or maybe you're making 2 data source calls inside of one of your resolvers. That's going to be up to your team's decisions of how you want to orchestrate that, keeping in mind that there's things like the caching layer in there. And actually, I skipped over one of the polls that I think is a good one. How many people are doing some form of caching? Why don't we launch the caching poll? Yeah. Right. So Apollo REST data source is connected internally to a caching mechanism. Do you have any caching things that you put in your APIs? One of the things we didn't quite cover yet was around CDN caching, which is there. And so, CDN caching is something that can be supported through automatic persisted queries in Apollo server outside the box. Very common for a lot of teams to do that, but curious to see what teams have about that. I'll share the results in just a minute. I'm going to go through a couple of questions while people are answering just to maximize our time. Doesn't breaking down the API into smaller chunks based on what we care increase the traffic over the network? I always consider number of requests to API when I create my schema and query. Yeah, definitely. But there's kind of a couple different lights that people could be coming from. If you're coming from a world where you have like BFFs or orchestration layers that have gotten built up over time, I think one of the common ones is like, I have a search service that returns like everything, and it's like been built up over time. And yeah, decreasing that, like if you cut out the products and you only just use the product IDs, and then you had another service that did the products, you're now increasing a ton of traffic, right? But this is now a world where you're probably going to want to start destructuring that search service, and that's a certain architectural pattern decision that team might go down. Where there's also other teams that might say like, our APIs are very well defined. I've had teams say this, like this is the way we do these certain domains. Like our business has been around for 20 years. Like those aren't changing. We need those exactly. And it's totally fine to put those in there, one-to-one, in there. You just don't want to do it everywhere, right? And there's definitely gonna be areas you're gonna find where it's like, we want to expose our capabilities in this way, but it's too expensive to expose it on the graph that way. And maybe that means you can't go down that route because there's business limitations inside of there, right? You're not going to get funding to take those next steps because the payoff for the change to the app isn't going to be there. One of my recommendations in there, if you're trying to gain steam and like speed on getting your graph into production over REST, find another part on the graph that's going to be impactful and maybe a little bit easier of a first implementation. Now, we're just about at time. I did see one last question that I just want to say inside of here. I am going to put the code up on GitHub. I will put it out there. What I'll do is the community post where I get a bunch of these questions and try and answer them. I'll put the link for the code inside of there, and then we'll find a way to email it to everyone who attended this so they can see that. I'm going to leave you with the results of our final poll here. So 37%, no caching. This is definitely not uncommon. I've seen a lot of teams do that. A lot of caching at the REST layer, some CDN caching, great. And then some caching at the GraphQL layer. I like that. I like to see more of that. I think the further we cache at the edge, the better. All right. Well, we're just at the top of the hour, everyone. Thank you so much for spending the last hour with me. I hope you found this really helpful. Like I said, the recording is going to be up online. We're going to make sure to reach out. I do have these getting started materials that I want to leave you with. We'll have this that's sent out along with a link to these slides. All this will be made available. And with that, thank you, everyone. Enjoy the rest of your day.